Hey guys, this is a little help for your test coming up on Chapter 2. I suggest that while we go through it, I wouldn't write the problems down, but I think you should make a note card while we go through it. So the first thing you need to do is know how to describe a pattern. So you'll notice this is going up 3, and then it goes down 2, then it goes up 3, then it goes down 2. So my guess is it's going to go up 3, then down 2, then up 3. And if we described it, we would say it's going down, up 3, then down 2, up 3, then down 2. The next one, a conditional statement. And I would write that on your note card. Conditional statement. And I think it's the A group, you already have that. I don't know the B group, I don't know how much of a note card you have going, but you have to write it in if-then form, so the if comes first. So for this one, we would say if, so the conditional statement goes if, and then there's what we call the hypothesis, then the conclusion. And the notation for that is P implies Q. P arrow Q. So we would say if the dog is scared, then it barks. So we need the if part first for a conditional statement. Then you need to know, and I put this on your note card, what a converse does. And again, some of you rewrote that on the note card. Sorry, that's supposed to be an S. The converse swaps the if and the then. So I call it the swap. So we would say if, but then this part would come first. So if Q, then P. And we say Q implies P. So back over here, the original says if the dog is scared, then it barks. The converse would reverse those and say if the dog barks, then it is scared. The inverse does what I call knots them or negates them. Leaves it in the same order though, so you should draw an arrow back up here. These are all about the conditional statement. The inverse says if not P, then not Q. So back over here, I'm going to rewrite this statement again. If, right here, the dog or a dog is scared, then it barks. All right, so like I said, that's the conditional statement. The converse swaps those and would say if the dog is barks, then it is scared. The inverse knots them, but keeps it in the same order. So it'd be if the dog is not scared, then it doesn't bark. So this guy right here is the inverse. It keeps it in the same order, but knots it. And we write, this little squiggle means not. So we write not P implies not Q with the notation. Okay? So write a biconditional statement for the conditional statement. Now a biconditional, again, let's put that over here. We're going to put what a contrapositive is first. Although it's not asked, it might be on your test. A contrapositive does both. I call it the swap and not. So the contrapositive puts the Q first, but negates it, and it implies not P. So it does both. It swaps it and knots it. So back over on the dog one here, if the dog is scared, then it barks. The contrapositive would have the barking first, but not barking. So it'd be if the dog doesn't bark, then it is not scared. We swap them and knot them. Next, and again, I would box these in on a note card, and as we go, we'll make a note card while we do examples. So the next up is the biconditional statement. A biconditional statement uses the phrase if and only if. And we do that if with two F's. And what it means is we insert that phrase, if and only if. So we would say, back to this one, the dog is scared if and only if it barks. All right? So if and only if for biconditional statements. If it's true both ways, we call it a definition. So find a counterexample. Back to the note card. A counterexample is one thing that proves the statement false. Just one thing. So one thing that proves, and you can write the statement false. So you need to just find one thing. So this says, if a polygon has four sides, then it is a rectangle. So can you find a four-sided polygon that's not a rectangle? Well, yeah, 1, 2, 3, 4. There's one, looks like kind of a boomerang. Or how about like a rhombus or a diamond? So a counterexample, let's just go ahead and call it a diamond. You can call it a rhombus or a trapezoid. There's lots of them. Trapezoids look like this. They're four sides, but they're not a rectangle. So counterexample is one thing that proves it false. All right, so is this a true biconditional statement? What that means is, does it work both ways? If x plus 7 equals 10, then x has to equal 3. That is true. Then we'll swap them. If x equals 3, then does x plus 7 have to equal 10? Yes. So this is true. If we had to write it, we'd say x plus 7 equals 10 if and only if x equals 3. Because again, biconditional statements require if and only if. That's what if with two F's means. Now it says write the contrapositive. All right, so let's go to our note card. A contrapositive does both. It swaps them and knots them. So what we're going to do is reverse the order or swap the if with the then while also inserting the word not. So if x does not equal 3, then x plus 7 does not equal 10. So notice I've swapped them and negated them, or swap and not. Find a counterexample. If the product, that means multiply, of two numbers is positive, then they both have to be positive. Usually when I ask this to kids, they'll go, oh, multiply two negatives, or have one of them be 0, because 0 isn't considered positive or negative. Or you could do like a -1 times a -5, and a negative times a negative is a positive, but we only need one counterexample, so I'm going to choose this one. But any two negative numbers would be good. When I am hungry, I eat. So you have to decide what comes first, the hunger or the eating, and it's the hunger. So when it says write the conditional statement, remember you should go back up, that's the if-then. If P, then Q. If not P, then not Q. The converse swaps them, if Q, then P, and the contrapositive swaps them and knots them. Okay, so when I am hungry, I eat. For the conditional statement, I have to decide what comes first, the hunger or the eating. And I'm saying when I'm hungry, so I'm saying if I am hungry, then I eat. That is called the conditional statement. Done. The inverse is the knotter. It knots them. You should have that written on your note card. We don't reverse the order. We just say if I am not hungry, then I don't eat. It's making me hungry. The converse, and again, you can always pause if I'm writing too fast. The converse just switches them, but you always go back to the conditional. So I'm going to say that if I, but I'm going to swap these. So the eating is going to come first. So I'm going to say if I eat, then I am hungry. It's kind of easy. You just make sure you have that written on your note card, right? And last up, the contrapositive, which is the swap and not. Okay, so we go back to the original for the contrapositive. We go back to the original, we swap them, so we have the eating come first, the hunger comes second, but we negate them, or say not in it. So I would say, if I don't eat, then I am not hungry. So make sure you know the difference between these and have them written on your note card. The conditional is just if this, then that. The inverse is the notter. Keep it in the same order, but now we're not hungry and we're not eating. The converse swaps them. And the contrapositive does both. Next page. The law of detachment and syllogism. You don't really need to know what they are. You just need to know if a valid conclusion's been made. It says, if it rains really hard, then my basement will flood. Then it says my basement flooded. For the law of detachment, you have to have the if part stated. You have to have it say, it rained hard. And then you can say my basement flooded. Okay, so this one is a no, and you might want to write on your note card for the law of detachment. And again, I would keep a note card running. For the law of detachment, it says, if P, then Q. In this case, P is it rains really hard, Q is my basement flooded. Okay? If P, then Q. They have to say P happens for you to conclude Q happens. It has to be the if part, not the then. This guy is following a train of thought. If I eat peas, then I get hives. So I ate peas. Well, that means I got hives. It's an if-then statement. So this is yes. And this is the law of syllogism. It doesn't really matter that you know their names. You just have to know that you can conclude that. The angles are complementary if and only if they add up to 90 degrees. Here's that phrase, if and only if. We should have on our note card that that's a biconditional statement. Okay. Write the two statements that make the biconditional. So it's got two things. It's this, if the angles are complementary, then they add up to 90 degrees. Now we switch it. Okay? So the biconditional statement has that word if and only if, and it's combining two if-then statements. If the angles are complementary, then they add up to 90. If the angles add up to 90, then they are complementary. So we write the original and the converse when it says, write the two statements that make this one. So if I said, I cry if and only if I am sad, I'd say, if I cry, then I'm sad. If I'm sad, then I cry. You just write them as two separate statements. It says, is this true or false? This is true. It's the definition of complementary angles. If the angles are complementary, I know they have to add up to 90 degrees. And likewise, if I know two angles add up to 90 degrees, I get to call them complementary angles. So it works both ways. Be prepared to write a proof that deals with the segment addition postulate. Remember, the first reason in any proof is the given. How do I know from A to C is 17? Well, because they told me. The next thing they didn't tell me, which means it has to come from the picture. Why is it that AB plus BC equals AC? Why is that? That's the segment addition postulate. It says the two pieces add up to the whole way. Well, now all of a sudden, AB is out and 3x minus 1 is in. BC is out and 5x plus 2 is in. AC's out and 17 is in. What I've just done is some substitution. Okay? For these algebra ones, it's basically what you do is the name of the property. If you substitute, it's substitution. If you combine like terms, which is on this next one, you write combine like terms, or CLT. Now it says subtraction was used. Well, what would you subtract over here? You'd get 8x equals 16 as your statement. And then how do I go from, and again with these proofs, you're always looking at one step to the next. What would I do to get from here to here? I would subtract. What would I do to get from here to here? I would divide. So I call it division property. And you can write property of equality if you would like to. So moving right along here to the next page. This one says find the measure of ABC. Well, I can't until I know what x is. So what equation can I set up? Well, these two angles together make a straight angle or a line, which means together they have to add up to 180. So then we use our algebra skills and we combine those like terms. We subtract 6. We get 13x equals 174. Is that right? And then I would divide both sides by 13. What's 174 divided by 13? Doesn't come out very nice. 13x plus 6 equals 180. I wish I had made one that came out a little nicer, but I'm just going to leave it as x equals 174 13ths, I guess. That certainly isn't very user-friendly, so I apologize for that. It'll come out nice on your test. And then remember, once you get the x, you have to go plug it in. So if I had a 10, I'd do 10 times 10 plus 4. I cry if I am sad. The hypothesis is what comes after the word if. It goes if P, and P is the hypothesis, then Q, and Q is the conclusion. You might want to write that on your note card. But after the if is the hypothesis. Okay? So the hypothesis is that I am sad. And when I am sad, what's the conclusion? I cry. Okay? So hypothesis is the if. If I am sad. Okay? Last up, I think this is the last one. Again, it's just a little brief review, yep. So for this last one here, we are going to go take a look at this proof. Remember, the very first statement, its reason is always because they gave it to me. You can't get that wrong. The next statement they didn't give to me. This is all that was given, which means it must come from the picture. So you go over the picture and you say, well, why is angle 1 the same as angle 3? And those are called vertical angles. So you can write vertical angles, or they allow you to write vertical angle theorem, or that stands for vertical angle theorem. Now what's happening to say that 3 is the same as 4? On the picture, there's no reason for me to say that. But if 1 is 4 and 1 is 3, it means both 4 and 3 are the same as 1. So we get to say, well, forget about 1. Those are the same. And we call that the transitive property. I call it skip the middleman. Right? If Bob is the same age as Sue and George is the same age as Sue, well, forget about Sue. Bob and George are the same age. That's called the transitive property of equality. Okay, so that was a little help. It wasn't, you should be doing the practice test for your class as well, but hopefully that's helpful. Have a good one.